All right, let's just jump right into it. AI coding assistants, right? They're one of the biggest things happening in tech. I mean, they're making billions, and it feels like pretty much every developer is using them. But what if I told you the data shows they might actually be making expert developers slower? Yeah, this is the AI coding paradox.
So first, let's just look at the money, because it's staggering. Tools like Claude Code have hit a $2.5 billion annualized run rate. That's not just a successful product, that's an absolute juggernaut. It's no wonder enterprise companies are pouring cash into this tech.
And the adoption rate? It's just as massive, 92%. That's how many developers now say they use AI tools in their daily workflow. So this isn't some niche thing for early adopters. It's become a standard piece of the toolkit for pretty much the entire industry.
Okay, but here's where the whole story takes a very sharp turn. A really rigorous, controlled trial found that experienced developers using these exact same tools were actually 19% slower. Not faster, slower. Yeah, you heard that right.
So that's the big question, right? That's the mystery we're going to try to unravel here. How can this possibly be? How can a tool be a massive commercial success, a developer favorite, and yet, when you put it to the test, it actually hurts performance? Let's break it down.
To really get the paradox, we have to start with the promise, because the hype, the excitement, it's not really just about typing code a little faster. It's about a much bigger, much more ambitious idea, something called workflow compression. And the idea here, it's actually really powerful. It's not about auto-completing a line of code. It's about shrinking the whole messy process of software development, from figuring out the code base to planning changes to actually testing them and squishing it all down into one single seamless conversation. And this table just lays it out perfectly. Look at the column on the left, the traditional way. You're manually digging through files, you're writing up separate design docs, you're editing files one at a time. Now look at the agent workflow on the right. It pulls all of that together. It gets rid of all that context switching that just chews up a developer's day.
And if you want to see this in the wild, look no further than Spotify. They've gone all in on this. They built an internal system, they call it Honk, that bakes these AI agents right into the core of how their developers work.
And the results they're reporting are just, well, they're kind of nuts. A 90% drop in the time it takes to do certain big engineering jobs, over 650 pull requests generated by AI getting shipped every single month. You see, this completely changes what it means to be an engineer. You're not just a writer anymore, you're a reviewer, an approver.
Okay, so the promise is huge, and we've got giants like Spotify showing these incredible results. But now we have to pivot. Let's look at what the broader, more controlled studies are telling us. And this is where perception really starts to collide with reality.
This chart, right here, this is the entire paradox in one image. In that controlled trial, developers felt like they were flying. They perceived a 20% speed up. But the stopwatch, it told a totally different story, a 19% slowdown. That's a 39-point gap between how fast they felt they were going and how fast they were actually going.
As the author of our source material, Thorsten Meyer, puts it so well, this gap is where big, expensive strategies just completely fall apart. When you're spending millions based on a feeling of productivity that the data doesn't back up, you are setting yourself up for failure.
So, where did all that time go? I mean, it has to go somewhere, right? Well, here's the critical finding from the research. The bottleneck doesn't just vanish, it moves. All the time you think you're saving by writing the initial code faster, you lose it and then some later on in the process.
And here's the brutal math. The AI-generated pull requests, they're 154% larger, which leads to review times that are 91% longer. Code churn, that's code that gets written and then almost immediately has to be rewritten, it doubled. And maybe the scariest number of all, a whopping 45% of AI-generated code has security flaws. The work just piles up further down the line.
And it gets deeper than just lost productivity. When you start deploying these tools at a massive scale, you introduce this whole new category of really serious operational risks that, frankly, most companies haven't even started thinking about yet. Let's look at what breaks.
We can basically group these risks into three big buckets. There's something called prompt context drift, a huge policy enforcement gap, and what's known as a reproducibility deficit. Let's break those down. So first, prompt context drift. The easiest way to think about this is that the AI agent basically has amnesia. Every time a developer starts a new chat, the agent forgets the context from the last one.
It's like having a conversation with someone who can't remember what you said 5 minutes ago, and you can imagine how that leads to inconsistent, even conflicting, code across a team. Next up, the policy enforcement gap. This one is pretty stark. You ask companies what their top priority is, and 75% of them will tell you it's security. But then you ask how many have a real, advanced security strategy for AI? It's only 6%. That means you have these incredibly powerful AI agents running around without the proper guardrails. And finally, there's the reproducibility deficit. Look, if an AI makes a change to your code, but you didn't log the prompt that was used, the model version, and all the context it had, that change becomes a black box. You can't explain it, not to an auditor, not to a regulator, not even to the next developer who has to work on it. And that's a massive compliance and liability nightmare waiting to happen. So, okay, given all these risks, it becomes pretty clear that the goal has to shift. The real race here, it's not about raw coding speed anymore. It's about building a system of governance to actually manage this incredible power and do it in a way that creates real, lasting value. And the good news is there are some very clear, practical things leaders can do. They need to standardize the policies for how these agents are used. They need to demand that every single AI-generated change comes with metadata. They need to separate permissions. Letting someone explore with an agent is very different from letting them deploy its code. And crucially, they have to measure the entire pipeline, not just that first step. Which leads us to the new metric. The one metric that really cuts through the hype, the rework rate. This simply tracks how much of that AI-generated code has to be fixed or even thrown away after it's been merged. This is the number that tells you if you're actually being productive or if you're just creating future problems, what we call technical debt, at a much faster rate.
So this brings us all the way back to the beginning. If this whole mad dash for more speed is maybe the wrong race to be running, then what is the right one? What should we actually be focused on?
And this really is the bottom line. The race isn't about which agent can type the fastest. It's about which agent produces high-quality, reliable, and auditable code that doesn't need to be immediately fixed. The winner isn't the fastest. It's the one that gets it right the first time and can prove it